One of these times. One more time.
Okay, I guess I must have done that, huh? Since you all know the line. All right. What we're doing today is finding the area between curves. So we start out easy with finding the area between a function like this and the x-axis, okay? Which is the integral of negative x squared minus 2x plus 24.
Is it from negative 6 to 4?
Yeah, no, you did that wrong.
From negative 6 to 4. How did I get negative 6 to 4?
Because it's on the x-axis.
Because it goes from negative 6 to 4 on the x-axis. So, negative 1/3 x cubed minus x squared plus 24x from 4 to negative 6. And you stick in the numbers.
You don't divide by anything? Where's the C?
There is no C when it's because we have numbers. Okay, so it's a definite integral. So there's no C's in definite integrals. Okay, so it's negative 1/3 times 64 minus 16 plus 24 times 4, which is 96, minus negative 6 cubed is negative 216 times negative 1/3, so positive 108, minus 36 minus 144. 1/3 of 64 is negative 64 thirds. This is negative or plus 80, so it's plus 240 thirds minus, this is 160, 180 minus 108, so minus 72 minus a negative 72, so plus a positive 72, right? So 240 minus 64, what's 240 minus 64?
176.
176 thirds plus 3 times s is 216 thirds. This is, so then this is 400, nope, 92 thirds.
Wait, when did we? Yeah.
Uh-oh, I did something wrong because that's not one of the answers.
Divide it by 3.
Yeah, but it
Oh, wait.
isn't divisible by 3.
Did you not have to divide by the distance between those two?
No, it's not an average value. So I did something slightly wrong here. But you guys get the idea? Now, you go, boy, that's a lot of work. Well, do you want to save yourself some work? So if we go y equals, and we put in the function, the original function, 24 minus 2x minus x squared, and you graph it, and you go second trace, and then we go 7. The integral from negative 6 up to 4 is 166 and 2/3. So it's 500 over 3. So I must have zinged when I should have zanged somewhere along the line. Okay? All right. Now, this one's a little more complicated. So you kind of want to pay attention to this one. We already know what the area of the region is. We got to figure out what K is. So we have to work backwards. No, not plus C. We got to work backwards. All right. So this is the integral of 2 square root of x from where to where? 0 to k is going to be equal to 32 thirds. Okay? So if we integrate 2x, 2 square root of x, this is x to the 1/2, right? So it becomes x to the 3/2 with a 2/3 in front times 2, which is 4/3 in front, equals 32 thirds. See what just happened there? Okay, we just integrated. If we multiply both sides by 3, 4x to 3/2 equals 32. Divide x to 3/2 equals 8. Take the cube root of both sides. So x to the 1/2 equals 2. So x equals, if we square both sides, 4. K must equal 4. Okay, Eli.
What if you don't know where it starts?
Yeah, like this
Like, what if it
problem.
doesn't start at 0?
Yeah. This problem.
Yeah,
I
because
do I
it's
figure it out now?
we'll figure it out.
This one. This one.
All right. What about the region in between two curves? All right. Could we use our graphing calculator for that?
Yeah.
Oh, yes, we can.
Thank you.
All right. So here we go. So under y1, we're going to type in x squared minus 4x plus 1. Under y2, we're going to type in 3x minus 5. Now, what we got to do is we have to graph it, and you guys have colored graphing calculators, which will help you. Colored graphing calculators. But we're going to graph this. And you see a curve there and a straight line there. Which one is above from 1 to 4? Which one is above the other one?
The straight line.
The 3x minus 5. So we have to take the top line minus the bottom line. That's the rule. Okay? So we could integrate this all and do all kinds of work, or we could just take the graphing calculator and say, turn you off, but don't clear it out. Turn you off. Go down here, turn you off. Go down here, trust me, and go second var, no, go, sorry, not second vars, go vars, and then over to y vars and function, and go y2, and then minus, and then vars, y vars, function, y1. So we're taking the y2 function minus the y1 function, and then we're going to graph that. So we're going to graph where the new function of subtracting them. Then we're going to integrate from 1 to 4. And if we go from 1 to 4, it's 13 and a half, which is 27 over 2.
Imagine how much work that would be. I can't even imagine.
Yeah. Wild.
Probably just cry.
Okay?
Probably. Would this be the one that you get to use your calculator on the test?
Yes, you should. Most of these you can use your calculator on the test. This one you might not. Okay? This one,
Oh, it's for sure. I was thinking the same thing.
it's either B or C, because see how it's a natural log? Okay, so let's look at this one. If we look at the function 4 over x, anything over x looks like this, right? The other function is like this. Oh, actually, it's like this as well. So definitely the 5 is on the top, and we're finding the area in between these two. Okay? So the 5 is on the top. So it's the integral from -2 to 2, or -2 to -6 to -2. There we go. Of 5 minus 4 over x. Because we take the top minus the bottom. Let's integrate it. What's the integral of 5?
It's
5x. What's the integral of 4 over x?
4
4 ln of x. From -2 to -6. So if we plug those in, we get -10 minus 4 ln of -2 minus -30 minus 4 ln of -6. So if we combine like terms, so we go plus, positive, is this minus? Yeah, I think that's what it is. Okay, so if we go -10 plus 30, we get 20 minus 4 ln of -2 plus 4 ln of -6, which is 4 ln. And if we combine these two with addition, it's multiplication. So it's 4 ln of 12. So do we have a 20 minus 4 ln of 12? No, we don't. So what we have to do is take the 4 and make it a power. So it's the ln of -2 to the 4th plus ln of -6 to the 4th. 2 to the 4th is what? Ln of 16 plus the ln of something. So in the end, we're going to get 20 ln of 81. Because we have a 20 here, and it's -10 plus 30. So it can't be -10. And then with these, I don't think they cancel out. Ooh.
Just a guess. So all know is you gonna get got to the exact same point where I was at the beginning. You just had the right answer.
Yeah, sure.
You are.
Then, when we get to these, okay, where is our starting and ending point? Hey, shh,
-8 and 7.
we don't know where they are. So we have to graph them out first. So what I'm going to do, I'm going to turn this one off, and I'm going to clear out what's in my first two. Clear, clear. So, in my first one is 3x squared plus 3x minus 8. The second one is 2x squared plus x plus 7. Then we'll graph them. Then we got to see which one is above the other one. The second one is above the first one, right? Where do they?
How do you know that's the second one?
Because it was graphed second.
Plus
The
7.
first one went, and then the second one went. Okay. All right. So let me change my window. Because my window for the x's is fine, but for my y's, I need to go way up. I'm going to go up to 50 and graph it. Because I got to see where they cross. Okay? And where they cross is where we're going to start our integral and end our integral. So I'll go second trace and find out where they intersect, and then go enter, enter, enter over there. And they're going to intersect at 3. So our integral is going to go from 3 to somewhere. And then I'm going to go back to the other side. So I'm going to go second trace intersect 5. And I'm got to run to the other side where the intersection is. And then I'm going to go enter, enter, enter. And then once I go enter, 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 if my cursor is right by the intersection, it tells me where it's at. So it's -5. So I have to take the integral of this one minus this one from -5 to 3. So if I do that on my calculator, thank goodness we have calculators, second trace, 7, and I'm going, oh, I got to go wrong. I got to go turn these two off because it's the second one minus the first one. and turn this last one on.
How are you doing that?
You press enter over the top of the equal sign to turn them off and on. So if we go second, or if we go graph it. So now it looks like that, and now we have to find the area in between the curve and 0. Second trace, 7. So I'm going from -5 to 3. And then it's 85 1/3. 85 1/3 is 3 times 85, which is 256. Okay? And the last one, a trig one. Okay? So if it's a trig one, we're going to take the integral of the sine of x and then 1/2. So if we look at the sine curve starts at 0. At pi over 2, we're at 1. At pi, we're at 0 again, so it goes like this. Okay? 1/2 is a straight line like this. Okay? So we're finding this area in between these two, in between the sine of x and 1/2. Okay? So if we're going to do that, we're going to integrate minus 1/2 because the sine is above the other one. Where do they intersect? Where is the sine equal to 1/2 at? Pi over 3. Pi over 6, I mean. And 5 pi over 6, if you know your unit circle. If you look at your unit circle and look at the sine, it's 1/2 at pi over 6 and 5 pi over 6. So that's what you're going to do. So let's write out the integral. What's the integral of sine? Negative cosine of x. What's the integral of negative 1/2? Negative 1/2 x from 5 pi over 6 to pi over 6. So what's the cosine at, what's the negative of the cosine of 5 pi over 6? It's negative of negative square root of 3 over 2, which is positive square root of 3 over 2, minus 1/2 of 5 pi over 6, which is 5 pi over 12, minus, okay, if we put in a pi over 6, negative the cosine of pi over 6. What's the cosine of pi over 6? Square root of 3 over 2, minus 1/2 of pi over 6, which is pi over 12. So we get plus a positive. So square root of 3 over 2 plus square root of 3 over 2 is square root of 3, or 2 square root of 3 over 2, or just square root of 3. This is minus 5 pi over 12. Minus of 1 pi over 12 is negative 4 pi over 12, which is minus 4 pi over 12, which is pi over 3, right? So square root of 3 minus pi over 3. Ta-da. So that's the basics of what we're doing today. Have fun with that. Get going.